right, this is our third lesson in the slope series. Remember, we have been finding slope graphically and using 2 points. And in this lesson, we are going to find the slope of a line from a table of values. Now, we've been making these tables both on our skill builders and as we've done lessons. So let's check it out. Let me go forward here. Remember, there are 4 kinds of slope: positive, negative, zero, undefined. The vertical line is undefined because we can't divide by 0. And in our last lesson, we looked at the formula. And so here we are today finding the slope from a table. When we found slope graphically, we used rise over run, and we made slope blocks, slope steps, and we're able to determine positive, negative by looking at the line, using the rise and the run. When we only had 2 points to work with, we used the slope formula, y2 minus y1 over x2 minus x1. Great, no worries. But now what happens when we get to a table? When we get to a table, we're going to actually be looking at something called the change in y over the change in x. I want to take a minute and I'm going to cover that up so I can write here. Make a note of this, that in mathematics, when we work with, I need to, bear with me just a minute. I need to just get that out of the way. If you'll just bear with me just a minute. So in mathematics, oh no, that's in the way. I'm so sorry. Let's try that one more time. I don't want to remake the video. So bear with me as we try this one more time. I'm going to cover that up so I can show you. All right, in mathematics, a triangle, which is the Greek letter delta, is used as a symbol of change. All right, as you progress in mathematics, you're going to see the delta quite often. You might even have this read delta y over delta x. Because we know that the delta symbol means change, we'll also say the change in y over the change in x. Well, how do we get the change in x? Well, when we use the slope formula, we subtract the 2 y values, and we get the change in x by subtracting the 2 x values. But when we're dealing with tables, and many times, it's much simpler than that. Let's take a look. All right, so look at this. Look at this table. This is a table. It says the number of friends and the cost of a party. This represents our x values. 0 friends, 1 friend. That would be a sad party. You mean to tell me that a party, even without your friends, is going to cost $85? Man, I guess that's a lot of pizza for one person, but whatever. Now, 1 person, 2 people, 3 people. These are our x values. The cost of our party, y, 85. If 1 person shows up, it's 91. If 2 people show up, it's 97. If 3, and so on. Maybe we're also buying a ticket. I don't know. Ticket to a movie or something. I don't know. But look what we can do here. Remember, we're looking at the change in y over the change in x. Well, we can just look at the y column and see that every time as I go from 0 to 1, I have a change of $6. When I go to 1 to 2, I have a change of $6. So I know that my delta y is 6. If I look at my x column, I know that there is a change of 1 person each time. So my delta x is 1. So my slope given this table is 6. Easy peasy lemon squeezy. Let's look at some more of those. Again, here we have this shows you a table and its corresponding graph. All right, but look, our delta y every time is positive 60. I'm increasing by 60 every time. And my delta x, I'm increasing by 1 hour every time. That gives me a slope of 60 over 1, 60 miles per hour. Here, we notice that I don't know what these values represent, but all I need to know is an x and a y. Here, from each ordered pair, my y is increasing by 3. Each time my y increases by 3, and my x increases by y. So my delta y, I'm sorry, by 1. My delta y is 3. My delta x is 1. My slope is 3. Piece of cake. So here are some that they haven't done for us. We just want to take a minute. It tells us that we need to find the delta x and the delta y, create a slope, and explain whether this slope is positive or negative, or maybe even the line is vertical. We'll see. All right, so let's start here. How are my y's changing? Increasing by 2 each time. How are my x's changing? Increasing by 1 each time. So my slope is 2 over 1, and it's positive. Here, this time I'm decreasing by 3 each time in my y. My delta y is a decrease of 3. My delta x is an increase of 1. So my slope is negative 3 over 1, or a slope of negative 3. It's a negative slope. Here, I'm increasing. Look, these are negative numbers, but these negative numbers are getting smaller. So I'm increasing by 4, increasing by 4, increasing by 4. Here, I'm increasing by 1. My slope is 4 over 1. It's positive. Now, if we have either the x column or the y column is all the same number, then what you're looking at is either a horizontal or a vertical line. So take a minute, figure it out. If the y is not changing, it's a horizontal line because we would have 0 in our numerator. If the x does not change, we would have a vertical line because that would be a 0 in our denominator line. Vertical line, and the slope would be undefined. However, sometimes when we look at a table, we notice, things aren't always right with the world. To go from negative 9 to 11, wow, that's 18. That's an increase of 18. To go from 11 to 27, that's not 18, that's 16. To go from 27 to 35, that's an increase of wait, something's wrong here. And these aren't the same. So that tells us one of two things. Either this is not a linear equation, in which case we're not concerned right away with slope, or I don't have all the data I need. And so if I know for a fact that it's a linear equation, I'll teach you a little bit later on in the year how to determine if it's linear or nonlinear. But for right now, if I know that it's linear, I can just take 2 points. I'm going to call this point 1. I'm going to call this point 2. And I'm going to use my formula. So I would end up saying 35 minus 27, which represents my change in y. I would take 9 minus 2, which represents my change in x. Do the math here. I get 9 over 2. I have a slope of 9 over 2. I sure hope I did the math correctly. I didn't do the math correctly. That's not 9. I hate when that happens. It's, oh my gosh, it's 8. The slope is 4. Oh my gosh, I can't believe I messed this up completely. Hey folks, I'm not going to redo this video. I'm thinking more about the video than I am my numbers. The slope is 4 over 7. Oh my gosh, 14 over 7, which is 2. It's late on a Sunday afternoon, folks. The slope of this line is positive 2. I may still not have done the math correctly here. Oh, help me. Help me. All right. These are some examples of ones where trying to figure out the change as we go forward. There does not appear to be a constant rate of change, but I'm told that these are linear equations. So I'm going to try one more time to get this correct. And then we'll close the video. I'm going to choose 2 points. Folks, I could choose any 2 points I want, but it's always a good idea to avoid negative numbers when you can. So let me redeem myself by doing this much better. So my change in y is 20 minus 8. My change in x is 5 minus 2. So my slope, remember I use m to represent slope, is 12 over 3, which reduces to 4. The slope given this is 4. So you can go through and work on those if you would like. Please, again, forgive my math errors before. I think you get the gist of this. Slope from tables is pretty simple going forward. And when it doesn't work, when it's not evident what the change in y and the change in x is, drop back and punt and use your slope formula. Okay, have a great day.